So far, we've seen that in every transaction object, a table is created for each level to store its data and retrieve it later. Transactions, naturally, are used to perform insertions, modifications, and deletions in those tables through their screen, and, in addition, to navigate and retrieve data from those tables. We've already seen that we can associate a data provider with a transaction in order to populate its tables with data. In that scenario, the data provider is used only for initialization. Then the transaction will behave normally. In other words, it'll access its tables as usual to retrieve the data, and will allow inserting, updating, and deleting records as usual. Note that the update policy property takes the updatable value to enable these updates and this behavior. But we can also change this transaction's behavior and prevent the data from being updated. That is, once the tables with data have been initialized, they cannot be modified, and no new data can be added. To do this, you must change the update policy, which by default takes the updatable value and sets it to read-only. We will now see that it's possible to continue using the transaction as usual, but without storing the data in the associated tables. In short, we'll have a case of transactions from which no tables are created in the application's database. We can achieve this by indicating that the data provider associated with the transaction will be used to retrieve data. But if no tables are created, somehow we'll have to specify where the information will be retrieved from every time the user wants to browse his or her data. In addition, we'll have to indicate what to do when the user enters data on the screen and wants to insert, update, or delete it from the corresponding tables. To insert, update, or delete, we'll have to explicitly program 3 events with these names. To retrieve the transaction's data, we'll have to program the data provider associated with it. Just like data population, the update policy property will allow us to indicate if the transaction can be used only to retrieve information or also to update it. Let's see an example. We'll open Genexus. Let's suppose that we have 2 standard transactions. Invoice, to represent the invoices issued by the travel agency to its clients for purchasing tickets, trips, and so on. These invoices are identified with a sequential number. And receipts, to represent the receipts issued by the travel agency to its clients for their purchases. Receipts are also identified with sequential numbers. The accounting system of the travel agency needs to handle these invoices and receipts as documents in general, to then be able to handle these documents in accounting movements. First, we create the document transaction with an identifier made up by document type and document ID. Why do we need a compound identifier? In order to determine, for example, whether we're dealing with invoice 1 or receipt 1. This transaction will be like a view that will unify the information contained in the invoice and receipt tables. In other words, it will not create a table to contain the data. Instead, it'll take it from the tables corresponding to invoice and receipt. To this end, we set its data provider property to true and indicate that we'll use this data provider to receive information. After that, Genexus will automatically understand that the table associated with the transaction must not be created, because this data provider will be used to indicate from where to obtain the data. In this case, it'll be from the invoice and receipt tables associated with the corresponding transactions. Let's return to Genexus. We already defined the transaction document with its identifier consisting of document ID and document type, and selected the corresponding properties. The document type attribute is based on the type enumerated domain that takes the values of invoice and receipt. Okay, let's look at the source of the data provider associated with this transaction. We have a document group to retrieve all the documents that are invoices, and another group to retrieve all the documents that are receipts. From now on, every time the transaction is run to navigate its data, this data provider will be run to load the corresponding information on the screen, in a completely transparent way for both the developer and the user. Nobody will notice that the transaction doesn't have a table. Let's see this at runtime. We press F5. We must take a look at the impact analysis report, which clearly says that document is a dynamic transaction. We'll reorganize and execute the document transaction. Invoices and receipts are integrated, and we can run through this information without noticing that there's no associated table. Okay, after this, the dynamic transaction is used as any other transaction. For example, to print all the documents ordered by date in descending order, we can create a procedure with a for each command similar to this. In the print block, we'll have inserted the attributes corresponding to document as usual, and Genexus will obtain this data from the data provider that contains its logic. It's interesting to note that in this for each command, document is declared as a base transaction. And from this, since the attributes mentioned in the print block belong to document, Genexus determines that the base table of this for each command is document. But document does not exist as a table in our database, but as a view through the data provider. To see it running, let's select Run on this list. Transactions are not only used to retrieve their data, but also to update it. How do we go about it, since we don't have a table associated with this transaction? Let's look at the Update Policy property. If this property is set to Updatable, the events Insert, Update, and Delete will be offered in the transaction to program how to insert, update, and delete the data entered by the user on the screen. Only the developer will know what to do in each case with this information. These actions will be enabled depending on the reality. Suppose that these actions are enabled in our example. Look at the form of the transaction. When the user has finished completing the fields in this screen to insert a new document and has pressed the Confirm button, we will have to insert a new record in the invoice or receipt table as appropriate. This depends on the value entered in the document type attribute. So, let's look at the events sector of the transaction. We've programmed the insert event using the invoice and receipt variables based on the invoice and receipt business component data types, respectively. Previously, we set to true the business component property of each of these transactions. Note that we could have used the save method instead of the insert method of the business component. We don't need to write the commit command because we're in the document transaction that still has the commit on exit property set to yes by default. In other words, it'll implicitly run the commit. Now let's see how to code the update event. Since we don't know which field was changed by the user, we assign all the values and apply the update method to the business component variable. Finally, the delete event to remove the record from either the invoice or the receipt as appropriate, applying the delete method to the business component variable. Let's see what happens if we have rules stated at the dynamic transaction level. When are they triggered? What happens with the evaluation tree? Both the evaluation tree and the rule triggering moments are the same as if we were dealing with a regular transaction. For example, suppose we have the following rules stated in the document transaction. We're assigning today's date by default and checking that the amount is greater than 0. Let's see it at runtime. We press F5. We execute the document transaction. We see today's date by default, and we'll first insert an invoice with the amount of $2,500. We'll now try to insert a new invoice, but leave the amount at 0. And the error rule is now triggered. As for the success or failure messages triggered during the execution of the business components, invoice, and receipt, we can also retrieve them. To this end, we set the messages variable based on the message's data type, a collection, as a parameter in each of the insert, update, and delete events at the transaction level. These messages are displayed in the form of the dynamic transaction in a completely transparent way. As an example, let's go to the rules of the invoice transaction, and suppose we've declared this error rule that controls that the date cannot be later than the current date. So let's run our dynamic document transaction again and try to insert an invoice with tomorrow's date through it. We press F5 and run document again. We insert a new invoice, but use a date later than the current date. When we confirm, the form of this dynamic transaction shows the message of the error rule that we've declared in the invoice transaction. Moving forward with this example, remember that we've said that the travel agency's accounting system needs to handle all documents as accounting movements. Since the document table associated to the document transaction will not be created, we can assume that then in the movement table associated with the standard movement transaction, the pair of attributes made up of document type and document ID cannot constitute the foreign key that they should. So what's going to happen with the referential integrity check? Can Genexus make it? Since referential integrity must be ensured, Genexus generates SQL triggers to do so. Therefore, it could be said that the pair document type and document ID make up a pseudo-foreign key in movement. In sum, in document, it won't be possible to delete invoices or receipts that have an associated movement. In addition, it won't be possible to add a movement that doesn't exist as a document. Let's review the concepts that we've learned. When the data provider property at a transaction level takes the true value, Genexus asks us what we're going to use it for. If we indicate that we'll use it to populate the table with data, then the transaction will generate its corresponding associated tables. Through the update policy property, we will allow, or not, the updating of records in the usual way. When the data provider property associated with the transaction is set to true, and we indicate that we're going to use it to receive data, Genexus understands that the transaction will not have any associated tables, and that it will make a view from that data provider. Then, according to the value that we indicate in the update policy itself, the corresponding events should be programmed to allow the insertion, modification, or deletion of records in the corresponding tables. Finally, it's worth mentioning that we've seen a single use case of dynamic transactions, but there are multiple cases, such as selection, data grouping, and temporary relationships that we'll address in other courses. You can access more information using the link on the screen.